Hello everyone, in this video we will present you our signal processing project. One biggest world environmental issue is waste. For example, big landfill sites are created in Malaysia because of European waste. With this project, we try to bring an innovative solution to this issue. Our project consists in studying the operation of what we call a smart bin. A bin of this type is capable of selective sorting in total autonomy. The goal is to do the sorting instead of the user. First, the recycling of waste begins with the sorting of this. But in our daily lives, often because of lack of time and lack of knowledge, we don't sort well our waste. The smart bin is a potential solution that needs to be developed, and we already found existing prototypes of those intelligence bins, such as the bin E. This bin is placed in shopping centers, offices, and large public spaces. With the help of sensors, image recognition, and artificial intelligence, this bin is able to separate metal, paper, plastic, and gas. R3D3 is another intelligent bin, and the particularity of this bin is that it is connected. Indeed, when the container is full, she sends a notification to the cleaning services to be emptied.
So we wondered if we could come up with new methods that will improve the everyday waste treatment.
We have based on the frequency of the sound that waste makes when we throw it in the trash. Indeed, each material, having different weight and density, will not have the same sound. During our experience, we studied 3 types of waste: glass, metal, and plastic. We first recorded the sounds and then edited them with Audacity to make them usable. Then, under MATLAB, we observed the frequency spectra of the 3 signals obtained by applying a Fourier transform. We noticed that each one has its own spectrum well distinct from the others. We can therefore identify a material by its sound. The system will only have to compare the frequency of its record with those contained in the sound database. This method seems to be effective in sorting waste automatically. However, we can criticize it. Actually, it exists within a material different variations of this material that will have slightly different sounds. Therefore, it will be surely more sensible to store ranges of frequency values rather than one single frequency value for each material.
So, after that, we decided to create our own sorting device. So, we created the device, and on the little clock here, you will see if the waste is made of glass, plastic, or metal. First, we will sort the waste with a magnetic field, so every waste attracted to it, we won't have to sort it with signal treatment. So this is the first one that has been sorted with magnetic field. After that, we will take another kind of waste. This one isn't attracted to the magnetic field, and if when it fall down, we could see that it went down to metal. The second one is made of glass, so isn't attracted to the magnetic field too, and when we will drop it, it's at glass. And the third one is plastic, so it isn't attracted to the magnetic field too, and when it will drop, it's at plastic. So we managed to create a device that is able to sort different kind of waste. This is a little comeback to the clock so that you can see where is glass, plastic, and metal. So to conclude, this was a very interesting project and we can still improve it. The subject was interesting, and it was interesting because this is a very present problem with the recent scandal in Malaysia. And so we believe that every big company will have to come up with a solution stronger than ours, and we won't be the last one to work on that. Thank you for listening. We hope you enjoyed our video.